Today we're going to talk about section 3.8, solving equations and formulas. First, specified variables. So let's go straight into the examples so you can see what I'm talking about. So far, all the problems that we've done have only had one variable. Now we're going to talk about what happens when you have more than one variable in the problem. So the first equation is 3x minus 4y equals 7. And the directions will give us that we want to solve for y. So we want to get y totally alone. But there are some certain things we can do right away and other things we can't. Now, I know that ultimately, or maybe some of you are thinking, we'll get rid of that 4 first. But we need to actually work from far away from the variable to close to the variable. So we actually want to move this whole term first. Now, here's one way I explain to my students. Imagine that this is the girlfriend in the couple, okay? The girlfriend is not going to give up her boyfriend. So here's two couples. Here's couple number 1, couple number 2. We're trying to get the girl alone. So what we want to do, she's not going to give up her boyfriend. She's going to give up that other couple first. So that piece that's further away, we're going to move that first. And to move that whole term to the other side, like we learned in section 3, 5 variables on both sides, we're just going to subtract that 3x to move it to the other side because we want to solve for y. So we subtract 3x, we're moving the entire couple into the other room, if you want to think about it that way. So that entire couple is gone. We're still left with the negative boyfriend, -4, and the girl. And then over here you have to be careful. We cannot combine a constant with a number, a term that has a variable on it. These cannot be squished together. You can't do 4x because this is not an x. These are not like terms, which can be tricky if you don't pay close attention. Now, basically we're just going to be subtracting these. So there are two ways you could write it. You could write 7 minus 3x, or in order to prepare us for solving equations of lines for a variable, it will be better for us to bring this variable down first. So this is a -3x, we bring it down first. This 7 is positive, so we bring that down second. You cannot squish them together because they are not like terms, so you just bring them down. Now that the girl has given up her best friend and her boyfriend, so the other couple, they're moved to the other room. Now she's going to be giving up her boyfriend last. That's the last thing she gets rid of. So we do this the same way we always did it. If y is being multiplied by -4, then we have to undo that by dividing by -4. And there's a couple ways you can do this over here on this side as well. So I'll show you both ways, and then it depends on what way your teacher wants you to give it. But if we want to divide by -4, that means we need to divide every term by -4. So there's one term, two terms, each of those need to be divided by -4. So this drops out and we get y equals, this you can't simplify and you should not change this to a decimal. The only thing you can simplify is that a negative divided by a negative is a positive. So this stays positive 3/4 with an x, and then a positive divided by a negative is going to make this negative, and you can just leave this as 7/4 if you want. For now, just leave them as improper fractions, reduce them if you can, but leave them like that. The other way that you can leave it is that you divide the whole thing by -4, like this, and then you could leave it like this. Now, I prefer this because it allows us to simplify any pieces that can be simplified. This is the way that we would like to do it in class, okay? So we're trying to get y alone because that's what the directions say. Move the other term, the whole term, away first by undoing addition and subtraction, and then undo the multiplication and the division. So it's similar in that we're moving addition and subtraction first, but now we're talking about a coefficient and a variable with it that we're moving to the other side. So if we try another example, number 2 here, we've got -3x plus b, that's a b, equals 6x. And we're solving for x. Now this one, might seem trickier because it's got a variable, it's got an x on the left side and the right side, but you need to collect all the x's together. They have to be together on one side. So we're going to start by moving this 3x over to the other side. It's the smaller of the two, so we want to move it over by adding 3x to both sides. These drop out, and we get b equals 9x. And pretty simple, if we want to solve for x, we're just getting rid of this 9, so we divide both sides by 9, and we get x equals b over 9, or flip it around, x equals b over 9. Now these we generally don't put in set notation, so it's okay if you leave them just like so. This one, okay? Let's try another example. Number 3. Negative 5a plus y equals negative 5y. So again, we're solving for a, and again we want to collect all the y's on one side. So we've got to move this y over to this y. That y is a positive y, so we subtract that y. So collect all the y's on one side, and those will drop out, which leaves us with negative 5a. Negative 5y and negative y. Now this is different from the previous problem we just did. These are both y's, so we can actually combine these two together. Negative 5y plus a negative y would be negative 6y. Keep going back to your goal. Your goal is to solve for a. So if we want to get a alone, no problem. Divide both sides by negative 5. And we get a equals, now we can simplify this, a negative 6 divided by a negative 5 gives you positive 6/5 y. And the y can be up there with the 6 in the fraction, or it can be next to the fraction. So there's several ways that you can answer this that would still be correct. Okay, let's try another one. 4z plus b equals 2z plus c, and we want to solve for z. Okay, again, we've got to collect all the z's to one side. So as soon as you see that your goal is to solve for z, and you see that there are z's on both sides, your first goal is to get all the z's together. So we're going to move the smaller of the two z's, like we did when we had variables on both sides. The 2z is smaller, so we subtract 2z because it's a positive 2z. 4z minus 2z gives me 2z. They don't really drop out, but these two drop out. Then we have plus b equals c. Go back to your goal. Your goal is to solve for z. All right, now here we've got the girl and her boyfriend and the other boy, okay? So she's going to give up the other friend first. So we're going to move this other term over, addition and subtraction first, so we subtract b. You need to be careful here. On the left side, no problem, we got 2z. Here, we have two different variables that cannot be pushed together, so we're left with just c minus b. C minus b. That's it. Just write it horizontally instead of vertically. And go back to your goal again. We're solving for z. So we divide everything by 2. And z equals c over 2 minus b over 2. Z is alone. And we're separating these into two separate terms here. Okay. Let's keep going. We've got a couple more examples. Number 5. Oops, no parentheses yet. We have y plus a over 3 equals c. Okay? We want to solve for y. Now we've seen problems that look like this before. We've got a fraction on the left side or the right side. We need to get rid of that denominator first. So we multiply the left side by 3 over 1 and the right side by 3. This side is easy, we get 3c, but be very careful on this side. This 3 will cancel with this 3. That's the whole point of us multiplying by 3 over 1, is to get those to cancel, and we're left with y plus a. Multiply through by the denominator. Go back to your goal, solve for y. No problem. We got to get rid of this a, so we subtract a from both sides. Y equals 3c minus a. Easy. Why don't you give this one a try on your own? Number 6. 4x minus 3y equals 9. We're solving for y. Try that one on your own. Push pause, come back and check it on. See how you did. Okay, let's see what you did. Now, we've got y, which we're solving for. There's the girl, the boy, the other couple. She's going to give up the whole couple, her friend and the other guy, first. The other term needs to move first. Undo addition and subtraction first. So that's a positive 4x, so we subtract 4x and move that to the other side. Did you do that first? If you did, give yourself a check. Those cancel, and we're left with negative 3y equals. Now, be careful here. This is a 9. This is an x. They are not like terms. And like I said in example number 1, for future purposes, it would be best if we bring the x down first. So we're just bringing these two things down. This is a negative 4x. This is a positive 9 because it has no sign on. It's understood to be positive. Okay, go back to your goal. We're solving for y, so we divide everything by a negative 3. These drop out. We get y equals a negative divided by a negative makes that positive 4/3 x. 9 divided by negative 3 will give us negative 3. And this is foreshadowing to a future section where we're solving for slope-intercept form. This is called slope-intercept form. Now, before we complete this, let's add one more section on your Cornell note sheet that's not there. Down here, at the back says translate word problems into proportions. We're going to add one in here, solving variables for a given. We're solving formulas for a given variable. You can add that on. Solving formulas for a given variable. Okay? Number 1, you want to move, well, let's say, collect common variables on one side. On one side. Okay, so if there's z's on both sides, get all the z's together. Then the next step, we'll call it 2, move other terms away. So we undo addition or subtraction, and that's that other couple, the other couple. Move the other couple into the other room first. Then get the variable alone, which is going to be multiplication or division, usually division. Okay, and that's that. Okay, so try to follow these steps as you're working through. Remember, if you have any questions or you're confused, you can always rewind and go back and watch it again.